What is up, you guys? Welcome back to my channel. I hope you're all doing well. I know that we've been in this whole pandemic situation for quite a while now, and I just like the things that I do to actually pass time right now is things like going on TikTok binges, and I don't think I like it. Right now I have this one song that is one of those TikTok dances that is stuck in my head and I can't get it out, and I know what you mean. It's just like, it's the noodle dance, you know, the whole like ta 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 na 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 na, you know what I mean. Even the one boomer that is eventually going to watch this video, because data analytics is for everyone, knows what I'm talking about, and it's bad. And so to give you guys hopefully something else to do than go on TikTok binges and fill your nights with Netflix, I figured I'm going to talk about how to study data analytics and do it yourself and do it at home, and give you all the courses and all the resources that I would recommend and I know about. So this is what we're going to be talking about in today's video, and I'm really excited. I love data analytics. I've been working in the field of data for the past 4 years, and I'm completely self-taught as a data analyst, so I kind of know what I'm talking about in terms of teaching yourself this particular skill set. Data analytics is definitely a job of the future. It's such a good skill to add to almost any career track, so no matter what you're doing, I would definitely recommend watching this video and figuring if this is something that you would like to learn. In this video, I am going to be explaining what I would do if I was currently starting out and didn't know anything about data analytics. This is obviously my opinion. It's not the only way to do this, but based on my experience, this is how I would do things, and in this video I will be explaining to you where to start, what skills you should be looking at learning, what the process of analyzing data is, and I'll also be sharing some courses and resources that I think are very useful. I'll try and take a structured approach to explaining this, because I know that especially in the beginning there's so much information and so many options to choose from that it can be quite overwhelming, and that overwhelm can just get in the way of you learning. So I'll try and keep this as concise and as to the point as possible. And I know that this is going to be a long video just because I don't want to cut any corners. I want to provide as much value to you guys as possible, and so I will be leaving timestamps in the description box so that if you want to just get to a certain part of this, you can, and please feel free to skip around. And if you have to come back and get to a certain point in this video just to refresh, it's there, it's in the description box, feel free to use it. If after this video you have absolutely any questions about learning data analytics on your own, please leave the questions in the comments. I will get back to you. All the resources and all of the courses that I mentioned in this video are also linked in the description box. It's going to be a long description box, but it's all going to be in there so that you can reference it after you've watched this video. Before we get going, I just wanted to say, if you like this kind of content, if you'd like to see more of it in the future, please feel free to subscribe to this channel and ring the bell so that you never miss an upload. I'm also on Instagram and post content almost daily, so if you'd like some more nerdy content, go follow Young Female in Tech on Instagram. And to get some common misconceptions out of the way, I wanted to talk for a second about what the difference is between data analytics, data science, and statistics. Because a lot of the times people are tripping over the fact that I need a data science degree, I need a computer science degree, I need a math or statistics degree to be able to do this, and that is completely not true. And I wanted to talk about the differences just so that you understand, especially what the difference is between data analysts and data scientists, because I think those are too often confused with each other. So to start off with the definition of data analytics, it's the process of inspecting, cleaning, transforming, and analyzing data to support and inform decision making. And that's a super simple definition, and that's just the essence of what data analytics is. It is using data to support decision making. There are some different types of data analytics. The most common ones that you'll probably hear are descriptive, prescriptive, and predictive data analytics. And as much as that is a mouthful, descriptive data analytics is basically reporting or describing something that has already happened. Prescriptive analytics are usually analytics that describe what action should be taken in case of an event happening, and predictive analytics are trying to gauge the likelihood of something happening in the future. That is a very basic explanation of all three, but those are probably the ones that you hear about the most. So then what's the difference between a data analyst and a data scientist? The entire purpose of the roles is completely different. Data analysts definitely focus the most on descriptive analytics, so basically describing events that have already happened, and a lot of this is reporting and describing past events through analytics. They communicate the insights that they find from the data to a large cross-functional audience, and their main role is to support recurring and ad hoc analysis for day-to-day decision making. So they're not necessarily involved in very high stakes big decisions that are made in the organization. They're super knowledgeable about key metrics and their domain, and so they are definitely experts on the organization and how they measure things. Data scientists, on the other hand, build models and algorithms to understand the data and interpret it. They have a way larger focus on predictive and prescriptive analytics, so looking at the future and any actions that might need to be taken. They design experiments to understand how different scenarios could possibly play out in the future. This means that obviously then data scientists' results and their experimentation might actually impact a lot of very high stake big decisions within an organization. And they are very involved in a larger variety of data operations such as data engineering. Generally, the requirements for data analysts and data scientists are also very different, but to become a data analyst, the qualifications of a data scientist are absolutely not necessary. So I would say give it a shot, because there's a huge demand for data analysts right now, because the amount of data that we're actually accumulating every single year is growing, and to use all of this data we need more data analysts. The more we incorporate smart technologies and smart devices into our lives, the more data we'll be actually gathering about ourselves, and to properly use it, there needs to be people that have data skills. And even in normal organizations right now, there's a huge crisis on not having enough people that are data literate. And I want to read to you from a Harvard Business Review article from this year about what 20 organizations have been describing that they need in their organizations. And it's not data scientists, like these are data analyst skills. Listen to me. For example, we recently conducted a focus group of 20 sophisticated companies telling us which data skills were missing in their own organizations. These analytics teams told us that they were not suffering from a lack of technical skills, but from skills in data-driven problem solving. They specifically mentioned people lacking the skills to ask the right questions, understand which data is relevant and how to test the validity of the data that they have, interpret the data well so the results are useful and meaningful, test hypotheses using A/B testing to see what results pan out, create easy to understand visualizations so leaders understand the results, and tell a story to help decision makers see the big picture and act on the results of analysis. And these are all data analyst skills. And so this is all what organizations are missing, not only in form of vacancies, but also skills that organizations desperately need in their own employees right now. This is also why data analytics is such a good skill set, because you can incorporate it into your current career without having to actually go into a data analyst role if that's what you want. So the next thing that I want to talk about is the process of analyzing data. And I separate this into activities that you can practice and learn on their own and then combine into a full-blown analytics process. And I want to keep this kind of simple. This is the beginning of your data analytics journey, so you don't need to know anything super elaborate, and that is why I'm focusing very much on the basics. And I'm getting a little distracted because one of our neighborhood cats is out there and she's really cute. But yeah, to get back to the topic, yes, you don't need to know anything super elaborate to get into the topic and start learning. So we're focusing on a couple of key steps here. The first step that you need to take on is identifying your question. And basically this means asking the right questions about your data and making sure that you're solving the right problem. Asking the right questions is a huge part of data analytics, and you need to be able to understand what you're trying to solve. Also, questions that you need to ask before you dive into the data, before you start any kind of analysis process, to make sure that there's nothing affecting your results that you're not aware of. And this could be anything from bias to bad data collection practices to poor data or missing data. And you need to know the answer to these questions before you go into any analysis of your data, because if you don't, you might end up with a result that is completely useless. And one great example of bias and a non-representative sample of data I want to give is, if you've ever read the book Invisible Women, exposing data bias in a world designed for men, looks like this. I'll link it down below as well. You'd be amazed how biased the data that has created our public transportation systems, transportation safety like seat belts, and in some cases even medicine has been. Men have been used as the default, and women have been basically assumed to be just like a man with a couple of different parts, and that has resulted in dangerous situations for women, because someone just didn't ask these questions in a non-biased way and identified that, you know what, like if you're only talking about a middle-aged white guy, then all you can study is a middle-aged white guy, and that doesn't apply to anybody else. So asking the right questions and asking yourself questions before you even go in to the analysis process saves you a ton of pain. So do that first. Make sure that that is a part of your process every single time, and you'll be good. The second step is to define and extract your data, and basically this means that you need to define the data points that you need in order to answer your problem or answer the questions that you want to find the answers to, and then go ahead and extract the data. Sometimes you might be getting the dataset already, but a lot of the times the dataset that you get might have extra data points that you don't need to actually answer the questions that you want. So you'd want to clean them out of your dataset just so that you don't process more data than you have to. Minimizing the data that you're looking at is a good practice from perspectives of just performance, because the more data you need to process, the slower it is, but also from the perspective of privacy, especially if you're working with data about people. The third step is clean and prep your data. And you'd think this takes less time than it does, but this might actually take you a bunch of time, and it's still something that you need to be doing because most data is shit, and the more you go into data analytics, the more you learn this. This might be anything from getting rid of missing values, or making sure that your data is correctly formatted so that you can use the methods that you want to use. And this is just something that needs to get done in order for the data to be usable to you. And the fourth step finally is to actually analyze the data. And a lot of methods for analysis are going to be covered in the courses that I'm going to go through a little bit later in this video. And so just hold on till then. I will go a little bit deeper into the topic then, but analysis is the fourth phase, and the fifth one finally is telling the story and visualizing your data. Every time you're analyzing data, you need to think about the audience that you're going to be presenting to, so that when you go ahead and visualize your data and create a story around it, it's compelling to the audience that you're trying to influence. It's a skill that you can practice and learn, and it's actually really fun because there's so many different methods to visualizing data that you can play around with and see what's your style, which methods do you like, what creates visualizations that you really enjoy and are intuitive to you, because a lot of the times the same ones could be intuitive for other people as well. So I think this is one of the probably like the funnest parts about doing this, because it gets so creative. And to go through with this process, you obviously need to choose the technologies to use, and today I'm going to be talking about SQL and Python. So what the heck is SQL actually? SQL, or SQL, you can pronounce it either way, is short for structured query language, also known as my love language. It is designed to manage data held in relational databases, and it's a 70s kid, so it's been around for quite a while. Whereas Python, on the other hand, is a general purpose object-oriented programming language. It was first published in the 90s, and it is definitely also very widely used. SQL is exclusively used for relational database management, whereas Python is used for all kinds of programming. Here is what SQL approximately looks like. This particular script that I completely randomly found online is basically just describing how to query a product ID, the product name, and how many units have been sold for that particular product. And you can see the result in the lower part of the screen, so where you have what looks like kind of a spreadsheet with the product ID, product name, and total quantity. And this is what Python looks like. Obviously, it looks a lot more complicated, and this is not necessarily a data analytics application. This seems like a machine learning model that is trying to categorize income. So which one should you choose? SQL or Python, you ask? And let's go through some pros and cons of each. For SQL, I would say the major pros for data analytics are that it is faster to learn than Python, and it will come back to haunt you if you don't learn it. I don't know if that's a pro, but it's more of a fact. So you'd probably need to learn it anyway. A lot of the Python libraries that are meant for extracting data from relational databases also rely on SQL. So even if you learn Python, you'd probably have to learn some SQL anyway. Cons for SQL are that it's really hard to join datasets from different sources, such as databases and spreadsheets. For example, if you are only using SQL, you could use ETL tools that is extract, transform, and load tool to work with more than one data source, but that is not only using SQL, so that would be a drawback of SQL as your only tool. It also doesn't have visualization capabilities, so you'd also have to use external software to do your visualizations and really tell your story. Probably Tableau or Power BI is what are most often used in combination with SQL. Python, however, is able to join datasets from different sources, and it's actually very agile in building the entire end-to-end analysis process from extracting your data to cleaning and prepping it to analyzing it and then visualizing it. That is a major pro of Python for data analytics. And in the con section, the one thing that Python does have is kind of a drawback, is that it is definitely more complex and slower to learn than SQL, especially if you want to master it. But at the same time, it is very useful, it is very agile, and definitely can complete the entire data analysis process for you. And to visualize that for you, here is what the data analysis process would look like for SQL and Python. Obviously for SQL, the last step, which is visualizing the data and actually telling your story, would have to happen somewhere else than in SQL. Other than that, you can complete everything in SQL, and in Python you can do everything in just that one particular technology. And you could obviously go ahead and choose either one of these, but if I were you and if I was still starting out, I would choose both. What I would do, I would first learn SQL, because databases and relational databases are something that every data analyst needs to understand. And whether you're learning SQL and using that as your day-to-day language, or going with Python, you're still going to be running into SQL all the time. Python libraries that are used to manage databases or extract data from relational databases are mostly based on SQL. So understanding SQL first just makes it easier to use the Python libraries that you would need to analyze data. SQL has been around for a long time and probably will be around for a long time, and it's such a staple in both a data analyst and a data scientist toolkit that I would definitely go ahead and learn it first. You don't need to go into like super complex SQL, and this is the next thing that I want to say in my own experience, because I think I probably could have learned Python a little bit earlier than I did. There are such cool tools to work with Python and build a portfolio of your own data analytics projects, such as Jupyter Notebooks, that I think working with Python for data analytics instead of SQL is smarter than just sticking with SQL. You can obviously just go with SQL if you want and use tools like Tableau and Power BI to visualize your analytics and your data, and that is, you can definitely build a career in data analytics with that just as well. But if I were to choose, I would learn both SQL and Python and do my analytics in Python. If you have any questions about that, leave them in the comments and I'll get back to you. I know that choosing language can be really hard, and there are others like R out there as well, but for these particular ones, I'd be more than happy to answer any questions that you have. Once you then figure out which technology you want to use, you obviously need to practice. And the best way I know how is doing your own projects. And once you start learning and you get into the flow of, you know, going through the entire data analysis workflow, showcasing what you know and what you've learned is also really important, just if you want to increase your chances of being employed as a data analyst. Some project ideas that I can think of just off the top of my head are, for example, thinking about what you know and figuring out what data is related to that. So let me explain a little bit. Whatever you're doing for a job right now, if it's not in data analytics, you can probably come up with some data that you use on a daily basis, and you might be thinking like, oh no, I can't. Even if you're working at a grocery store, think about sitting at the cash register and scanning an item. Somehow that computer knows what the item cost. It comes from a database. The barcode is an ID that the computer is querying from a database, and the database knows that this particular item with this ID costs a certain amount of money. At the same time, probably the fact that you scanned the item and someone paid for it gets logged, so the sale is being logged into a sales table. You probably also have a table that says like, okay, this particular item comes in this big of a package when it's ordered, and this is what it costs. And so if you take all of the data that I just described, you can already start analyzing things things like profit margins for the items that you're ordering, how much you need to order. It's honestly, it's that simple, like anything that you do in your current work. So that's number one for projects that I think could be really useful. There are a lot of open data sources that you can use, and I list a couple of them in the description, but websites like Kaggle or UN Open Data, EU Open Data, a lot of countries and cities have open data portals that you can use completely for free as long as you credit the source. You can just find almost any kind of a data set online and just use that to practice your data analytics skills and see what's interesting in the data. And if you're interested in learning more about data visualizations and especially Tableau, there's one particular Tableau challenge that has been going on for years and it's so cool. And it's the Monday Makeover Challenge, and it was started by a couple people that were very into Tableau, and so they found articles with visualizations that weren't that great in their opinion or could use some improving. So they challenged people to read the article, they linked the dataset that was used for the article, and then they asked people to actually make a better visualization in their opinion and submit it so that they could review all the visualizations that people are doing and what was good and what could be improved about them. And now they have this entire enormous repository of visualizations about different topics, and if you go through it you can just see how different visualizations people can make about the exact same data and how much creativity goes into that. So telling the story of your data is such a huge part about data analytics, and it's so exciting. And so I'll link that below as well if you want to actually go ahead and learn Tableau and take part in it, because I think it's such a great learning experience and you get so much inspiration from all the other submissions. And in order to use the skills, you obviously have to find the best way for you to learn. And I'm going to go through some courses that I know online that have a bit of a difference in how they teach, what they teach, and how you can practice your skills. So I'll be going through a variety of courses. All of them are again linked in the description so that you can find them easily, and some of them are free, some of them cost a little bit of money, some might cost money if you want the certificate for the course, and I'm going to be describing all of the pricing models once I go through the course, so just follow along and I'll let you know what is required for all of these courses. My absolute favorite for SQL has always been the Ultimate MySQL Bootcamp. Go from SQL beginner to expert on Udemy, and this is the one course that I took when I was first starting out and learning SQL. This took me about 3 weeks to complete. It says it's had 20 hours of on-demand video, but obviously you have a lot of practice in this one as well, which means that it'll definitely take you more than the 20 hours to complete. As of right now, I think if you're a beginner, it's like 23 euros, which is around $25-26, I think. And Udemy does discounts all the time, so you can probably find this for like 10 to 12 bucks at some point. Even if you pay 23 euros or 25 bucks, it's absolutely worth the investment. This is such a good course. You can see the overview of what's included in it, and one of the coolest features of this one was that the last capstone project is actually an Instagram database clone that you do and practice with. And I would say the bit that is not necessarily super important for SQL developers or SQL programmers is the introduction to Node. It's kind of a web app practice that they do, and that wasn't super useful for me, but other than that, this course is absolutely excellent. For both SQL and Python, I am absolutely obsessed with DataCamp. There are so many good things about DataCamp that I honestly probably failed to list all of them, but basically they have courses on all kinds of skills, and you can look at the skill tracks, which is one way to go about it. So if you need practice in Python, in SQL, or spreadsheets, you can all practice right here. And the cool thing is that they also do career tracks. So for data analysis, you have a data analyst with Python track. You can start with that. You also have data analyst with SQL Server. So if SQL is your chosen technology that you want to go with, definitely take that one. The Python one, I want to quickly show you what it looks like. So they have the entire process in here. So they do a quick introduction to data science. They do your Python toolboxes, an introduction to SQL functions, an introduction to relational databases, which is definitely a data analyst must have. They do cleaning data, one of the steps. They do data manipulation and merging, which is a part of processing your data. And then they do analysis and visualization courses, and also statistical thinking, which is a really great primer for the kind of statistical analysis that you might need to do in a data analyst job. So this is really great. They also have projects, and the projects are also insanely cool. So one very recent one is obviously visualizing COVID-19, but you can also do things like exploring Bitcoin cryptocurrency, and oh yeah, this was what I was looking for, a network analysis of Game of Thrones. So that's really, really cool. And any kinds of stuff from machine learning to analyzing baseball, almost whatever you are interested in, you can find here. The only drawback for this, I think, is the pricing. So you only have so many free courses in here. So to go premium would be $25 per month for the standard subscription, and the premium one is $33 per month. And honestly, this is completely worth it. Either one of these. With the premium one, you also get Tableau and Oracle content, which you don't get with the standard one. I'm in no way affiliated with this particular business or website. God, I wish, because I have recommended this to so many people. It's excellent. It's a little bit pricey. I think they're currently doing an offer that's like $199 for a year for the premium subscription, if I remember correctly, which is like 50% off of the yearly one. So obviously you can try it for a while and then see if you want to take the yearly one. But I used my entire year that my previous company paid for, and I'm probably gonna actually renew my subscription because this is amazing. For free resources, data analysis with Python from IBM is a very highly rated course on Coursera, and the syllabus is also very sound in terms of what you need to learn. So importing data sets, which means getting your data and then extracting it, doing data wrangling, which is a way of transforming your data, exploratory data analysis, as well as model development, model evaluation, and then a final assignment. So this has a lot of the basics of data analysis with Python. They also do courses with SQL. They do courses with R, like whatever you need to find, you can find on Coursera. You can enroll for free, and if you want the certificate, it's usually around $40. I don't know if you need it, to be fair. I think building your own projects and showcasing your learning that way is way better than getting a piece of paper, but if a certificate is what you want, you can definitely pay for that. I also do an introduction to data analysis using Excel, and even if you are familiar with Excel, I would definitely check out just some of the functions that you might not know. Pivot tables are an absolute must for a data analyst. Please learn pivot tables. They're also advanced graphing and charting and visualizing your data. So I would say there's a good chance that this particular course might have something that could still be helpful. And then lastly, data visualization and communication with Tableau from Duke University. Again, a very highly rated course, and goes through a ton of things in Tableau. But also what I really, really like about this is that it has a 2-hour section on asking the right questions, which is something that I talked about in the process of data analysis. So even if you don't want to learn Tableau, I would say check out that particular portion of this course. Everything's linked down below. Coursera generally has a ton of courses on data analysis and data science, so I would definitely check out what they have in each of the technologies, and all of them are free if you don't need the certificate. So that is a major benefit of Coursera. On the YouTube side of things, again, completely free resources, is Edureka, which is a channel that has a lot of programming related content. Not all of this will obviously be relevant to data analytics, but you see that there are a lot of, for example, Python tutorials, for example, Python pandas tutorials, Python programming, and Tableau as well. So a lot of the skills that you would need as a data analyst, you can also come here and check out tutorials on different skills. Another one very similar is Free Code Camp, that also does programming related tutorials and instructions. So for example, data analysis with Python, completely ad free. Go check them out. Serious props for all of the people that are actually creating these videos completely for free for people to watch. So some tips and resources that I also want to share, just so that you can keep practicing and find good solutions for your coding challenges that I'm sure are going to come your way. They do for all of us, and we're all just learning. So one really cool app that I found is called Enki, and it's a mobile app, and they have practices for all kinds of programming languages, including SQL and Python. And you can do just like 5 minutes of a daily mission, or that's what they call it, but a daily practice. And literally it's super simple. You can do it if you only have like a couple of minutes. You don't really feel like going through a whole coding exercise on your computer, but to just keep up the mindset and keep up with thinking about how to do things and thinking about the different skills that you're learning, even just like before bed, or maybe you have 5 minutes, you're waiting for your laundry to be done, or I don't know, like what do you do at home? And so using that is a super easy way to just like keep thinking about what you're learning. The best friend of every programmer in the world is Stack Overflow, which is just a community site where you can ask questions and answer questions about programming that other programmers can then answer and comment on. And for most questions that I have, I find the answer on Stack Overflow, and the joke is that 90% of programming is actually just searching Stack Overflow for answers. And so that is definitely a wonderful resource. Get familiar with it, use it, love it, live it, you know, embrace the fact that Googling is your new best friend. Another great resource, especially for SQL, is W3 Schools. It's a website with a lot of examples of how to use the different functions on SQL. So it's a super useful tool, especially in the beginning, or if you run into a function that you haven't really heard of. And you can just search it on the site and it'll give you examples of how to use it, both simple and also more advanced. And the last tip that I'm going to say is find community. A lot of the times we start learning something and we get a little demotivated, but having community, having people that are interested in the same things as you are, is really important. And I know that it's quite hard right now because we need to stay home. But I mean, as much as your learning is online, so is everyone else who's learning. So especially Instagram is such a great platform to find people that are interested in the same things. So a lot of us are actually on Instagram talking about the things that we're programming or learning or doing in terms of analytics or data science. And so you can find me on Instagram as Young Female in Tech, and find online communities that you can join in order to keep yourself motivated, but also ask questions and share successes. And that is it, you guys. That is my introduction to data analytics for beginners. I hope this video was useful to you. If it was helpful, give it a thumbs up. And if you'd like content like this in the future, subscribe to this channel and ring the bell so that you never miss an upload. You can find me on Instagram as Young Female in Tech. If you have absolutely any questions, please feel free to leave them down below in the comments and I'll get back to you. And if you're starting to learn data analytics, let me know in the comments. Let me know what technology you're going to start learning and what you're most excited about it. And that's a wrap. I hope you stay healthy, I hope you stay safe, and I will see you in the next one. Cheers.